Okay, students, friends, good morning to all of you. In second lecture of differential equation, we'll continue solution of differential equation. So let us begin lecture number 2 on differential equation, which is solution. And in solution, one very important thing is there, that is variable separable method. Now, what is the variable separable method? In this method, we write function of x with dx and function of y with dy, and then we will integrate. So let us begin variable separable method. Solve the following differential equations. Dy by dx is equal to 1 plus y square upon we have to separate variable. So function of y we will write with dy. So dy divided by 1 plus y square is equal to dx divided by. So we have separated variable. On integrating, we get integral dy upon 1 plus y square ds upon 1 plus x square plus constant of integration c. Integral 1 upon 1 plus y square dy is what? Tan inverse y is equal to tan inverse x plus c is required solution of given differential equation. Next is log dy by dx is equal to 2x plus 3y. We will eliminate log, so we'll get dy by dx e raised to 2x plus 3y. Dy by dx is equal to e raised to 2x into e raised to 3y. Dy upon e raised to 3y e raised to 2x dx. On integrating, integral e raised to minus 3y integral e raised to 2x e raised to minus 3y upon minus 3 e raised to 2x upon 2 minus 1 upon 3 is a required solution of given differential equation. Y minus x dy by dx is equal to 0. Therefore, y is equal to x, dx and x you bring on this side. Dx upon x is equal to dy upon y. On integrating we get integral dx upon x plus c1. Constant of integration we are taking c1. So log x is equal to log y. C1 can be replaced by log c. Constant we can adjust accordingly. C1 is equal to log c is constant. Log x is equal to log of cy. Is required general solution. Sec square x tan y dx plus sec square y tan x dy is equal to 0. See, this is dx. With dx we don't want tan y, and with dy we don't want tan x. Whatever we don't want, product of that will divide. Dividing by tan x tan y. We get sec square x upon tan x plus sec square y upon tan y dy is equal to 0. Now we have separated variable, so now we can integrate. On integrating we get sec square x upon tan x plus sec square y upon tan y is equal to c1. Numerators what? Derivative of denominator. So dy dx of tan x upon tan x dx plus dy dy of tan y upon tan y c1. Now this is f dash x upon fx will give you what? Log fx plus log 10y. C1 can be replaced by log c. C1 is equal to log c is constant. So log of 10x 10y therefore 10x 10y is equal to c. Is general solution of given differential equation. Next is cos x cos y dy. Plus minus sin x sin y dx. This is dy, we don't want cos x. Dx we don't want sin y. So divide by cos x into sin y. Dividing by cos x into sin y, we get cos y upon sin y minus sin x upon cos x. This is cot y on integrating we get integral cot y dy minus integral cot x dx is equal to c. 1. Integration of cot y is what? Log of sin y minus log of, this is tan x. Sin upon cos is what? Tan. And integral tan x is what? Log of sec x. Log c. C1 is equal to log c is constant. Log of sin y upon sec x therefore log will get eliminated. 1 upon sec is what? Cos into sin y is equal to c. Is required general solution of given differential equation. Sixth is dy by dx is equal to minus k, where k is constant. So dy is what? Minus k dx. On integrating we get integral dy is what? Minus k integral dx plus c. So y is equal to minus kx plus c. Is required general solution of given differential equation. Y square minus dy by dx is equal to x square dy by dx. Y square is equal to this, you transfer and take dy by dx common. So dx upon x square plus 1 is equal to dy upon on integrating we get 1 upon 1 plus y raised to minus 2 dy plus c. Integral of this is what? Tan inverse x y raised to minus 1 upon minus 1 we can bring minus 1 upon y on this side. Therefore, 1 upon y plus tan inverse x is equal to c is required general solution. Cos square y upon x dy plus cos square x upon y dx. Multiplying by xy y cos square y plus dy plus on integrating we get Therefore, cos square y is what? 1 plus cos 2y upon 2 plus x into 1 plus is equal to C1. We will multiply through it by 2. Y plus y cos 2y dy plus x plus x cos 2x to C1. Now separate. Integral y is what? Y square by 2. And integral of y cos 2y we will apply u into v. Y integral cos 2y minus an integral dy of y into integral cos 2y dy the whole dy by parts plus integral x is what? X square by 2. Again we'll apply integration by parts. So x integral cos 2x dx minus an integral derivative of x into integral cos 2x dx the whole dx is equal to 2c1. Therefore, y square by 2 plus y sin 2y divided by 2 minus derivative of y is 1 into sin 2y upon 2 dy plus this is dy plus x square by 2 plus x sin 2x upon 2 minus derivative of x is 1 into sin 2x upon 2 dx is equal to 2c1. We can take x square by 2 plus y square by 2 together. Plus x sin 2x, y sin 2y divided by 2 minus 1 by 2 will come outside. Integral sin 2y is what? Minus cos 2y upon 2 minus 1 by 2 outside integral sin 2x is what? Minus cos 2x upon 2 2c1. We can multiply through by 4. When you multiply by 4, this will become 2 times x square plus y square plus 2 times x sin 2x plus y cos 2x sin 2y, and minus into minus plus cos 2x plus cos 2y. 8c1, and 8c1 is replaced by constant c. Therefore 2 into x square plus y square plus 2 into x sin 2x plus y sin 2y plus cos 2x plus cos 2y. Eight c1 is c is constant. This is general solution of given differential equation. Next is 2 e raised to x plus 2y dx. Minus 3 dy is equal to 0. Law of indices will give you 2 e raised to x into e raised to 2y is equal to 3 dy. E raised to 2y divide on that side. 2 e raised to x dx is equal to 3 upon e raised to 2y dy. On integrating, we get 2 integral e raised to x dx, 3 integral e raised to minus 2y dy plus c. 2 e raised to x, 3 e raised to minus 2y upon minus 2 plus c. 3 upon 2 e raised to 2y. Bring this term on this side, so 2 e raised to x plus 3 upon 2 e raised to 2y is required 10th is dy by dx plus is equal to e raised to x plus y x square e raised to y. E raised to x into e raised to y. We can take e raised to y common. E raised to x plus dy upon e raised to y. So we have separated variable. Now integrate. On integrating we get e raised to minus y dy e raised to minus y upon minus 1 e raised to x plus x cube by 3 plus c is general solution of given differential equation. Next type is what? Here we find out constant of particular solution. Find particular solution of following differential equation. Which satisfies the given condition. In this first one is 3 e raised to x 10 y dx plus 1 plus e raised to x square y dy is equal to 0. And condition is what? When x is 0, y is pi. pi. Since 3 raised to x tan y dx plus 1 plus e raised to x sec square y dy is equal to 0. Here we don't want 1 plus e raised to x and here we don't want tan y. So product of that will divide. Dividing by tan y into 1 plus e raised to x. So 3 e raised to x upon plus sec square y upon tan y is equal to 0. On integrating we get 3 e raised to x upon 1 plus e raised to x plus sec square y upon tan y C1. Numerator is what? Derivative of denominator. dy of is equal to C1. 3 log plus log tan y log C. One plus e raised to x cube into tan y log C. Therefore, 1 plus e raised to x cube C is required. General solution. To find particular solution when x is 0, y is pi. Substituting in above general solution. So replace, it will become what? 1 plus e raised to 0 cube tan pi is C. 1 plus 1 cube, but tan pi is 0. So C will be 0. Now this value of C replace in general solution. That will give you particular solution. Substituting C is equal to 0 in above general solution, we get 1 plus e raised to x cube tan y is equal to 0 is required particular solution. Second one is x minus y square x dx. Minus y plus x square y is equal to 0 when x is to y is 0. This is condition to find particular solution. Since x minus y square x dx minus y plus x square y dy is equal to 0. Take x common, 1 minus y square dx, y common, 1 plus x square dy. Here we don't want 1 plus x square and here we don't want 1 minus y square. So dividing by 1 minus y square into 1 plus x square we get x upon 1 plus x square dx minus y upon, before integrating will multiply through by 2 because derivative of delta is what 2x plus minus 2y upon on integrating we get two x upon 1 plus x square dx plus minus 2y upon is equal to c1. Numerator is what? Derivative of denominator upon 1 plus x square now f del x upon fx is what? Log fx. C1 is what? Log c. Log a plus log b is what? Log ab is equal to log c. Therefore, 1 plus x square into 1 minus y square is equal to c. Is general solution of given differential equation. To find particular solution if x is to y 0. Substituting x is equal to 2 and y is equal to 0 in above general solution. So 1 plus 4 into 1 minus 0 is what c. C is 5. Substituting c is equal to 5 in above general solution. So 1 plus x square into 1 minus y square is equal to 5. A is required particular solution. Abhishek? नहीं हुए चलो से पूछो y into 1 plus log x y into 1 plus log x dx by dy minus x log x is equal to 0. And condition is what? X is 0 when y is e. Y is equal to e square when x is e. Since y into 1 plus log x dx by dy minus x log x 1 plus log x divided by x log x dx minus dy will go up divided by y. Dy upon y is equal to 0. Now we have separated variable. On integrating we get 1 plus log x upon x log x C1. Numerator is what? Derivative of denominator. D by dx of x log x upon x log x minus integral dy upon y is equal to C1. Log of x log x minus log y C1. Log of x log x upon y log c. C1 is what? Log c. Therefore, x log x upon, so x log x is what? Cy. Is required general solution. To find particular solution, if y is e squared and x is e, substituting in above, so e log e c e squared e into 1 upon e squared is what? C. So c is what? 1 upon e. Substituting c is equal to 1 upon e in above general solution. We get x log x 1 upon e into y. E into x log x is required particular solution. Fourth is e raised to y plus 1 cos x plus e raised to y sin x into dy by dx is equal to 0. When x is pi by 6, y is 0. Since e raised to y plus 1 cos x plus e raised to y sin x dx you cross multiply e raised to y plus 1 cos x dx plus e raised to y sin x dy is equal to 0. From here we don't want e raised to y plus 1 and from here sin x. So dividing by e raised to y plus 1 into sin x, we get cos x upon sin x plus e raised to y upon e raised to y plus 1 dy. On integrating we get C1. Integral cot x dx plus numerator is what? Derivative of this is log of sin x plus log of e raised to y plus 1 log c. C1 is equal to log c is constant. The log of sin x into e raised to y plus 1 is equal to log c. Therefore, sin x into e raised to y plus 1 is equal to c is required general solution. To find particular solution if x is pi by 6 and y is 0. Substituting x is equal to pi by 6 and y is equal to 0, in above general solution. So we'll get sin pi by 6 into e raised to 0 plus 1 is equal to c. Sin 30 is half, 1 plus 1, half into 2, so c is 1. Substituting c is equal to 1, in above general solution, we get sin x into e raised to y plus 1 is equal to 1 is a required particular solution. See fifth one, x plus 1 dy by dx. Minus 1 is equal to 2 e raised to minus y. Where y is 0, x is 1. Since x plus 1 dy by dx minus 1 is equal to 2, so x plus 1 dy by dx 1 plus 2 upon e raised to y. E raised to y plus 2 upon this, you bring on this side, y term. So e raised to y upon dx will go that side upon x plus 1. So we have separated variable, now we will integrate. On integrating we get e raised to y upon plus c1. Numerator is what? Derivative of denominator. This is log e raised to y plus 2 log x plus 1 plus log c. C1 is equal to log c. Is constant. Therefore, log of c into x plus 1. Therefore, e raised to y plus 2 c into x plus 1 is required general solution. To find particular solution if y0 x1. Substituting y is equal to 0 and in above general solution. E raised to 0 plus 2 1 plus 2 is equal to 2c. So c is 3 by 2. Substituting the value of c in equation, general solution. In above, we get e raised to y plus 2 is equal to 3 by 2 into x plus 1. 2 e raised to y plus 4, 3x plus 3. 2 e raised to y plus 1 is equal to 3x. Is required particular solution. Next is cos dy by dx is equal to a. And they given a belongs to positive integer. A is what? I. Condition given is what? Y0 is what? 2. Since cos dy by dx is equal to a, so dy by dx is what? Cos inverse a. Dy is what? Cos inverse a dx. On integrating, we get cos inverse a is constant, take outside, integral dx plus c. So y is equal to cos x cos inverse a is a required general solution. To find particular solution, if y0 is equal to 2, since y0 is equal to 2, this implies when x is 0, y is 2. Substituting y is equal to 2 and x is equal to 0 in above general solution. Replace 2 is equal to 0 plus C. C is 2. Substituting C in above general solution, we get y is equal to x cos inverse A plus 2 is required particular solution. Question number third type is reduce the following. Now see, we have seen that variable separable is possible. Then we can separate variable fx with dx and fy with dy. But when variable separable is not possible, then we have to apply substitution method. What is substitution method? For that, simple substitution is there, and after that, homogeneous differential equation, and then linear differential equation. So first, basic simple substitution. Reduce each of the following differential equation. Following differential equation to variable separable form. First one, dy by dx is what? Cos x plus y. It is so simple that we can very easily recognize what we need to substitute. Here we'll put x plus y as v. Put v is equal to x plus y. This x plus y will take as v. Differentiating with respect to x. So dv by dx is what? 1 plus dy by dx. So dy by dx is what? dv by dx minus 1. Therefore, equation 1 becomes dv by dx minus 1 cos v. dv by dx is what? 1 plus. Now we can separate variable. So dv upon now we can integrate it. Integral 1 plus cos v is what? 2 cos square v by 2. Integral dx plus c. 1 by 2 you take outside, sec square v by 2. So 1 upon 2 tan v by 2 divided by coefficient of v x plus c. Half will get cancelled. Tan v is what? X plus y. Is required General solution. I need some more page. Then add on page. Go to the toolbox. Toolbox. Subject. X minus y square dy by dx. A square. Put v is equal to x minus y. dv by dx is what? 1 minus dy by dx. So dy by dx is what? 1 minus dv by dx. Therefore, equation 1 becomes v square into bracket so 1 minus dv by dx is equal to a square upon v square. 1 minus a square upon v square is equal to dv by dx. So therefore v square upon v square minus a square dv is equal to dx. On integrating we get v square upon v square minus dx plus c. In numerator add and subtract a square plus a square therefore v square minus a square upon this is what 1 plus a square upon v square minus a square Integral 1 is what? V plus a square into 1 upon 2a log v minus a upon v plus a x plus c. Now replace the value of v, x minus y, plus a upon 2 log x minus y minus a plus a. X will get cancelled, transfer y on that side. A by 2 is required general solution. Third is x plus y dy by dx. Sec x square plus y square. Put v is equal to differentiating with respect to x. dv by dx is what? 2x plus 2y dy by dx. 1 by 2 dv by dx. X plus y dy by dx. So equation 1 becomes 1 by 2 dv by dx is equal to sec v dv upon sec v 2 dx. On integrating we get integral cos v dv is equal to 2 dx plus c. Integration of cos v is what? Sin v is equal to 2x plus c. Sin of x square plus y square is equal to 2x plus c is a required general solution. ऑलरेडी ये पेज आ गया है ना?
देखो कैसे है
ना ये?
और डुप्लीकेट करना है तो प्लस कर लो।
हाँ,
डुप्लीकेट कर लो
और
हाँ,
प्लस
और करना है तो इस पे डुप्लीकेट है ना वो देखो
ये
इसको आ जाओ
ये
नीचे आना
ये ना?
फिर से करो नहीं हुआ है
अच्छा, fourth one is cos square x minus 2y one minus 2 dy by dx. Put v is what? X minus 2y. Differentiating with respect to x. 1 minus 2 dy by dx. Therefore, equation 1 becomes cos square v is equal to dv by dx. So dx is what? dv upon on integrating we get sec square v dv plus c. Integral dx is what? X tan v plus c. X is equal to tan x minus 2y plus c is general solution of given differential equation. Fifth is 2x minus 2y plus 3 plus 3 dx minus x minus y plus 1 dy is equal to 0 when x is 0, y is 1. 2x minus 2y plus 3 dx is equal to x minus y plus 1 dy. Transfer dx on that side, bring this on this side. Therefore, dy by dx is what? 2x minus 2y plus 3 upon x minus y plus 1. So dy by dx is what? 2 common upon x minus y plus 1. Equation number 1. Put v is equal to x minus 1. Differentiating with respect to x, we get dv by dx got 1 minus dy by dx. So dy by dx is what? 1 minus dv by dx. Therefore, equation 1 becomes so 1 minus dv by dx 2v plus 3 upon v minus 1. Therefore, dv by dx is what? 1 minus 2v plus 3 upon v minus 1. V minus 1 minus 2v minus 3 upon v minus 1. Minus v minus 4. V minus 1 upon v plus 4 dv is equal to minus dx minus v took common. On integrating we get integral v minus 1 upon v plus 4 dv is equal to minus integral dx plus c. V plus 4 minus 5 upon separate it, so we'll give you what? 1 minus 5 upon v plus 4 This integral is what? V minus phi log and V is what? X minus Y. Minus X plus C. V is what? X minus Y minus phi log bring X on this side, minus X on this side. So 2X minus Y, 2X minus Y minus phi log plus 4 is equal to C. Is general solution. Condition given is what? Y is 0 when Y is 1. Is to find solution if X 0 Y 1. 0 minus 1, 0 minus 1 plus 4 is what? 3. Substituting C in equation in above general solution. Two X minus Y minus phi log X minus Y plus 4 is equal to minus 1 minus phi log 3. Bring all the terms on this side. Two x. Transfer log term on that side. Plus 1. Y plus pi log x minus y plus 4 5 common will give you what? Be honest and do your job honestly. Thank you.